Welcome, guys, and welcome back to another episode of Your Teacher Has Crazy Hair right now. We are going to finally start looking at a new set of standards that you guys are going to be responsible for. And if you take a look at what's highlighted, it says we're going to investigate the location of constellations in the sky and predict constellation, like where they're going to be. So we are going to start talking about constellations. We're finally starting astronomy. We're finally looking at things in space, not just science in general. We're going to start that astronomy the entire year by looking at constellations. And I just want you guys to know this mess of stars right here, that is not a constellation. It's a mess of stars. I'm going to have some questions that I want you to write down in your science journal. And I want you to leave a space in between each question. And the reason is that you're going to go back at the end of class today, at the end of the video today, and you're going to answer those questions in your science journal. So, question number 1, what is a constellation? Question number 2, why are constellations useful? Question number 3, how has that use changed over time? When I say over time, I mean hundreds up to thousands of years. Their use has changed. Write those down in your science journal and unpause when you guys have them written down. We're just going to jump in with a definition, all right? Throughout most of history, so throughout all but within the last, 60, 70, 80 years, constellations have been what most people think of them as, a picture in the sky. Everybody has played the connect the dot game when they were little. You connect dots in the sky to make a photo. You look up at the sky and see a bunch of stars, and you can do the same thing. You can connect the dots, and you can make a picture out of the stars that you guys can see. Well, when you do that, you get stuff that looks like this. All right, so this is Ursa Major. It's the Big Bear. The Big Dipper is actually part of Ursa Major. It's the bear's butt. But you can see that if you connect the lines for all of these stars, you get the outline of a bear. And Ursa means bear in Latin. Major means big. This is the Big Bear. And this is one of the more famous constellations, one that most people have heard of. So for most of history, constellations have simply been pictures, connected dot pictures up in the sky. What are they now? Well, modern astronomy doesn't care about the pictures, doesn't care about the shapes. What modern astronomy is looking at is the area that those shapes used to be in. Okay? So it is an area of the sky. It is not the shape that it takes up or creates. It's the area that shape takes up. They had the same names. So they kept, Ursa Major is still a constellation. But modern astronomers don't care that it's in the shape of a bear. They care that it is like what part of the sky it's in. And also, I don't know about you, but that outline to me doesn't look like a bear. Like, where's this guy's leg and his nose? I don't know. I think they were just making stuff up. So historically, you had all of these shapes, all of these patterns. This is Draco, the dragon. Here's that Big Dipper. So this would be Ursa Major right here. Little Dipper, Ursa Minor, is right here. This is Cygnus the Swan. So if you take a look at what it is today, Draco is this area of the sky. Ursa Major is this area of the sky. Ursa Minor would be this area of the sky. Cygnus the Swan is right here. If I have a supernova that I found and I want to tell other people where it's located, I can say it's located in the constellation Cygnus. That means that they are going to turn their telescopes and look at this area of the sky. So they don't care that it's this weird shape right here. They don't care about these stars in particular. They care about that area of the sky. You guys may have heard of the Perseid meteor shower. That just simply means that the meteor shower is coming from this area of the sky. Or the Cepheid meteor shower is coming from this area of the sky. That's all it means. It has nothing to do with shapes or pictures anymore. It's simply a location to look at up in our sky. A couple facts about them. There's 88 recognized by the IAU. The IAU is the International Astronomical Union, and they're the ones who vote on. They're professional astronomers, and they're the ones who vote on things like kicking out Pluto. How many constellations should we use? That's them. They meet every couple years, and we'll go into who the IAU is a little bit later this year when we talk about why Pluto got kicked out of being a planet. So there's 88 constellations. 31 are in the northern sky, and if you do some quick math, that means that there are more of them in the southern sky than there are in the northern sky. And they kept their historical names. So Ursa Major, that has been a constellation for thousands of years. It was the Babylonians, actually, that started making that stuff up, and then the Romans renamed them with their Latin names. But they've kept those names for thousands of years. Find my mouse. 57 are in the southern sky, and they don't have ancient counterparts. Why is that? Well, Rome was in the northern hemisphere. Greece was in the northern hemisphere. Babylon was in the northern hemisphere. And if you are the conquerors, you write the history books, which means that all of the giant civilizations who named these constellations, they're the ones who wrote the history books. Did people living in the southern hemisphere see stars? Yes. Did they make constellations? Yes. But unfortunately, over the centuries, most of them have kind of been unfortunately wiped out. Their names of constellations have not survived. So they don't have ancient counterparts, the constellations that are in the southern hemisphere, because the Romans and the Greeks never saw the southern hemisphere. So they didn't make constellations out of those stars. Now we have another word. It's called an asterism. An asterism, astro means star. So asterism is a group of stars that is not one of those 88 constellations. You may have remembered about 2 minutes ago, I said that the Big Dipper is part of Ursa Major. Ursa Major is a constellation that's recognized by the IAU, but everybody on planet Earth knows about the Big Dipper. The Big Dipper is not a constellation. It's a group of stars that people recognize, but it is not a constellation. The Little Dipper is the same way. It's a group of stars that people can recognize, point to it in the sky. It makes a shape, but it's not an actual constellation. It's not one of the 88. So those groups of stars are known as asterisms. Another one, Orion's belt. Orion would be an entire constellation. Orion's belt, those 3 stars in a straight line, people can recognize and point to. That is an asterism. That's part of another full-fledged constellation. Another important thing that you guys are going to need to know is what's known as the ecliptic. The ecliptic is the path that the sun follows as the Earth goes around the sun over the course of a year. So from our perspective, the sun is going to seem to be in front of a different group of stars at different points of the year. In January, if this is the sun, and here's the Earth, and it's January, well, there's a group of stars over here that we can't see that are behind the sun. But in March, well, now there's a different group of stars that are behind the sun. And in June, there's a different group of stars that are behind the sun. So as the year progresses, the sun is going to seem to be in a different place against the background stars. That line that the sun seems to travel throughout the year is what's known as the ecliptic. And if you are get there in a second. Here is our planet. This is way sped up, traveling around the sun. It's not to scale either, but our planet is traveling around the sun. And as it travels around the sun is going to seem to be in front of these stars and different point of the year these stars, at a different point of the year it will seem to be in front of these stars. The sun seems to travel through the night sky. If you are a constellation that the sun travels through, you are one of the constellations of the zodiac. Those are the 12 constellations that horoscopes are made out after everybody has a birth sign, Leo, Cancer, Gemini, Taurus, etc. Those are the signs of the zodiac. So we have the Earth. And the Earth is looking at the sun against a backdrop of stars. So we can look out into the night sky and we can see a bunch of stars, and the sun is going to seem to cover up some of those stars. Right now we are in August, so we have June. July is here in the Earth's orbit. While the Earth is here in the orbit, it would be August. This would be September. Right now we're in August, so we're somewhere in here. My birthday is actually in August, which means that during this time of the year, when we try to see stars that are on the other side of the sun, or the sun is seeming to cover up certain stars in the sky, what stars is it covering? It's covering up stars that are in the constellation Leo. Leo is my birth sign because I was born in August. My sister was born in June. So she was born while the Earth was over here in its orbit. What stars is the sun covering up? Well, if you go directly across, you're looking at the sun. My sister is a Gemini. Let's say you're born in March. Well, what sign would you be? If I was right here, this is little tiny Florida, I'm looking out. What stars are covered up by the sun? Pisces. If you're born in March, the beginning of March, you're going to be a Pisces. That's where the signs of the zodiac come from. That's how they determine what your birth sign is. It's where the Earth is in its orbit. That's going to make the sun appear to be in a different spot in the night sky, or to cover up a different set of stars. And if you're one of those 12 constellations that the sun travels through, then you're going to be a sign of the zodiac. So we have like a little animation, and this is way sped up, but as the year progresses, if we could see past the sun and not be blinded by it, you'll see that at certain points, the sun is in front of stars in Leo. As the year progresses, it'll be in front of stars in Sagittarius. As the year progresses, it'll be in front of stars in Pisces, and then Aries, and then Taurus. So this is all stars that are being covered by the sun at different points in the year. And that is where we get our signs of the zodiac. I want you guys to answer this question. How long does it take the sun to complete one circuit of the ecliptic? Answer is 1 year. A complete circuit of the ecliptic, if you start in one place in your orbit, you go all the way around the orbit so that the sun seems to appear to go around the entire sky, will take 1 year. One orbit of planet Earth. While we're looking up at the sky, a couple quick little notes about that. The simplest thing to do for astronomy is observation. In fact, it's one of the only things you can do. Within the last few years, we've been able to send a couple spacecraft up to things in space and bring back, like the moon, bring back some rocks, and you can touch them and do other forms of experiments. But for the most part, observation with your eyes and extending your eyes by using a telescope, that's really all you have with astronomy. If you have good eyesight, you can see roughly 5,000 stars. Most people can see between 4,000 and 5,000. If you have absolutely the best eyesight of any human to ever live, maybe a little bit more than 5,000. But of the hundreds of trillions of stars that are out there, we only get to see about 5,000. We can actually see only a very small amount, even of our own Milky Way galaxy. Most of it we can't see at all. The stars are too far away, and therefore they're going to be too dim for us to see with our naked eye. Quick little review. You group a bunch of stars into a shape, you get a constellation. Polaris is a star that's going to come up quite a bit. That's the North Star. As the Earth is spinning, Polaris is right here. So it seems to stand still as the Earth spins. It's almost directly above our North Pole. Astrology. When I started teaching astronomy a few years ago, I told my mom, and she's like, "You're teaching astrology? I love horoscopes." And I had to explain to my mom that I'm not teaching horoscopes, I'm not teaching astrology, I'm teaching astronomy. I'm teaching about the science of how space works, about planets and stars and galaxies, telescopes, NASA. Astrology is making stuff up. That's what it is. It's making predictions based on where stars are located and planets are located. It's not an actual science. I love my mom. But astrology is not the same as astronomy. All right. Why do constellations look the way that they do? It is only because of where Earth is located in space. If Earth was located in a different location, like around a different star, we would not have a single constellation the same. So let's take a look at the constellation of Orion. You'll notice that these three stars are in a line. You have Betelgeuse up here, a red giant who is about to go supernova within the next million years or so. But that is only from the perspective of planet Earth. These three stars that are in a line are actually nowhere near each other. They're quite a long distance away from one another. It's only from our perspective here on planet Earth that makes it look the way that it does. Here's the Big Dipper. All right. And if we look at the Big Dipper, you can see that there are a bunch of stars making up the, pot part of the dipper. Here's the handle. However, that's from our position on Earth. If you change that position and take a look at the actual stars, like if you're in a different position, that doesn't look like a dipper at all. If you change it in the other direction, let's say we're looking at this group of stars from this angle, that doesn't look like a dipper at all. So it's really only because of the angle that we're looking at these stars that we get any of these shapes anyways. What I would like you guys to do is go back and answer these 3 questions. After you are finished with this lesson, this video lesson, there's 2 things that I would like you to do. The first one is to watch an Edpuzzle titled "What Are Constellations?" When you are done with that Edpuzzle, I want you to fill out an exit ticket. How do you do that? Well, we don't have physical textbooks, but we do have digital versions, and this is the textbook the county bought for us. I want you to read, it's about 1 page long, the section on constellations. I've linked it to your assignment in Canvas. I want you to read through that little section and answer the 3 questions that are at the end and submit that.